Okay, so this video is to describe the design of my project for my CS2 final. The Frogger game you just saw, it was developed entirely within Qt using Q objects, particularly a Q graphics scene with Q graphics items in it, which I thought was the best, provided the best approach for the program. That'll be all be stuff you're familiar with if you study Qt for your final project, but this video is only going to go over the basic object-oriented approach and design and structure of my program. So with this diagram here, you can see we have a main class called game, which is in charge of running everything in our program, and it has a lot of objects in it. These objects all share similar qualities and they interact with each other pretty intimately. For example, movement is something shared by most of these objects. In fact, Lily is the only object that doesn't move. The lily pads are what your frog is trying to get to at the top part of the screen. Movement is handled only slightly differently object to object. Collision detection is also very vital to this program. It's the whole game. Collision detection between objects is also handled slightly differently. They all have to detect collisions, but for different purposes. For instance, in the case of a car or a truck, a collision would kill your frog. But in the case of a log, collision would not only keep your frog alive and keep it from drowning, but collision also moves the frog along with the log. And collision with the lily pad, in fact, wins the game. That's how you win the game, is by landing on a lily pad. It also has to restart your frog, and so those are the two main elements of the game, however, that you'll be basically encountering: movement and collision detection. So we'll start going through the description of each object. Car and truck are very similar. As you can see, they're actually identical at this stage. And that's because they do the same thing. A car and a truck both have a direction in which they travel and a speed at which they travel. They both involve movement, and they both have collision detection, which, as I said before, is in charge of killing your frog, basically, when they collide. These two objects could have been made into a single class, actually, called vehicle or something. And when you construct a vehicle, you could, for instance, specify whether you want a car or a truck. There are a lot of different designs you could implement. However, it would probably be best in terms of memory management, or cutting down on your code. But I thought having a separate object for car and truck seemed more intuitive at a high level. Also, I made the whole car object before I even started my truck class, so I just made them separate. Our next object, though, is logs, which is what your frog encounters on the river. A log is almost identical. It differs only, its only different attribute is its size. You have a large log, you have small logs. It has the same kind of movement. If you think about all these objects, they all have constant movement, but a log, its movement has to move the frog with it. That's basically what a log does. Now, when you think about a log initially, you think, well, a log is what keeps your frog alive, but that's not really what the log is responsible for. If you look at the log object, the log class objectively, all a log is supposed to do is it's supposed to have, sure, like a size, a speed, and a direction, and it's supposed to move up the river or down the river, and it's supposed to move anything on top of it along with it. It's a moving piece of land. So conceivably, not only a frog, but any sort of object that is on top of this log should be moved with it. It's not concerned about what might be next to it in the water, perhaps drowning, right? It's not worried about that. The log is only worried about its own movement, and so the only functionality I put into its movement is moving the frog with it. When it comes to the actual frog, or frog object, we can see it's a bit more involved. It has certain attributes but those are constant. You know, its size and its, you know, it changes direction whenever the little image turns to the right and left, but that's really easy to handle. The main purpose of our frog object uh, is its movement, right? That's the whole key to the game. In fact, that's all you can do in the game. You can't do anything but move your frog. And this movement is also in charge of collision detection. The frog is in charge of certain collision detection, right? Again, the frog won't know if it's collided with a car. The car is in charge of that, right? But the frog should know when it collides with certain things, like when it collides with water. You know, the frog should know that it's drowning. The frog should know when it's reached the end of the screen and it can't keep moving, right? It'll stop. That's the frog's responsibility. And also, interestingly, when it hits a lily pad, the frog has to be in charge of that kind of collision, which is maybe named a bit badly, because really what the collision detection with lily pads refers to is when it misses. If a frog lands in the bushes between lily pads, the frog dies. I don't quite understand why, but that's the way the game was invented, right? So the frog has to know when it doesn't hit a lily pad, and that's why that collision detection is there. The frog also has more functionality than the other objects. You can see it doesn't only have movement, it can reset, and that basically resets its position, right? That's important for when the frog dies, for when the frog actually makes it to the end, interestingly enough. And the frog is also, kind of in a morbid sense, in charge of its own death. The kill function is a member of the frog class. So basically when a car hits a frog, essentially in programming terms, the frog kind of kills itself, because we call the kill function from the frog class. It's a bit morbid, but the frog should be in charge of that as well, right? When it comes to our final object, Lily, it's quite different from the rest. It's non-moving, but it still has collision detection, right? A Lily knows that a frog lands on it, and then it does certain things. It also has a variable called empty. A Lily should be self-aware of whether or not it's empty, right? Whether there's a frog on it or not. If your frog is trying to land on a lily pad with a frog already in it, the lily shouldn't say congratulations. It should say, this lily is not empty, there's a frog already on here, right? And you handle that however you want to in the game. That's pretty much the overview of all the objects in the game. They all act similarly enough so that, you know, it's a very simple game. There's just a bunch of movement going on, but it can be a bit, the trick is to differentiate what's in charge of what, right? And looking at these objects separately and how they interact with each other. So to take only a small look at my code, here's my main function. If we look at the game header file, at least part of it, you don't have to worry too much about this syntax. If you learn Qt documentation, it's very well documented. They have a lot of good information on their official website. You can see that the game class doesn't have a lot of functionality. In fact, the only functions it has is to draw the logs, the vehicles, our little lives on the bottom right corner, create some lilies, create a frog. That's pretty much all the game is in charge of doing, and that makes sense from an object-oriented point of view. The game should just be in charge of creating these things, bringing them to life. And then the logs, the vehicles, the frog, they should all be in charge of their own movement. All the game has to worry about is making them. And so if we look at, for instance, one of these, we'll look at the car, right? It doesn't look that involved. It has a constructor, which you can see has a direction and a speed. That makes sense. Its only private member variables really are direction and speed, which obviously correlate with these. There's a constant, just how many pixels it moves at a time, but the only real function it has is move. Now you'll learn all about the what slots are if you learn Qt documentation, this QObject macro, and all of the syntax, so it doesn't really matter. What matters is the move function, which is all we really want this to do. It's the same for all of these objects pretty much. They all just are in charge of movement or whatever else. If we look at the lily, for instance, we have our bool empty, which is true by default, right? It's constructed, it has an accessor function for whether or not it's empty, and its main functionality is what I called check when. It's supposed to check when frogs have landed on it, and to see if, you know, if we've won the game, pretty much. This over here is a pretty cool aspect of Qt. You can, in this resource file, put all of these little files that you want. So all of your images, you can put them in here and then load them up into your program from the resource file. You can do the same with sounds, with all sorts of other things. A lot of the other small parts of my program, like the lives, it's really not very complicated to understand at all. I mean, that was pretty much, lives for instance was added at the very last minute. The game was pretty much as you see it now when I added those in. It's just a few images. When the frog dies, you know, you take one away. Once you have the basic layout, like here, it's very easy to add anything else that you might want, like you know, a next level, more objects, which are basically going to be very similar to these, and you know how they're going to interact, you know. If you want to add a second level where things move faster or there's more objects on screen, very easy to do. So that's pretty much a description of how the game works. I've included some links in the description to Qt documentation relevant to this, which is really useful, really good to look at and learn. It's very easy to learn online. And thank you very much for watching my video.